Hi everyone. Welcome to Tech Snippets. Today, we're diving into Python's try and except blocks. These are essential tools for handling errors in your code, ensuring your programs don't crash unexpectedly. Let's get started. Before we dive into try and except, let's talk about exceptions. In Python, an exception is an error that occurs during the execution of a program. For example, dividing by zero or trying to access a file that doesn't exist can cause exceptions. So, let's look at the basic syntax. In the try block, we place the code that might raise an error. In the except block, we handle the error and print a custom message to help identify the type of error. Let's understand this with a simple example. We'll try to divide two values. If no error occurs, the program will execute normally. However, if an error does occur, the except block will catch the exception and print a custom message to help identify the type of error. In this example, we divided 25 by 5, which returned 5 as the answer. This means there's no error in the code. If we simply try to divide 25 by 0, it will return a long error message, which can be difficult to understand. The try-except block is a powerful tool for developers, making it easier to identify and handle errors in a clean and efficient way. Simply, we need to wrap the risky code inside the try block. If an error occurs, the except block will catch it and display a custom error message. Let's understand this with another example. Suppose we have a program that takes two values as input. We want to catch exceptions if the user enters invalid values, like dividing by 0 or providing a non-integer input. Initially, we'll handle errors using a simple except block. But in this approach, if the user enters either 0 or a non-integer, like a string, the program will display the same generic error message every time. Let's run this program and test it by entering different values. First, we'll input two numeric values to see if the program returns the correct answer. Since the code is providing the correct result, it means no exceptions occurred during the execution of the program. Now, let's run the program again and enter a 0 as one of the values. You can see that it returns a custom error message, indicating that the value we entered is incorrect because division by 0 is not possible. Now, let's run the program again, but this time enter a string value as input. Notice that we still receive the same division by 0 error. This happens because we're not handling specific exceptions separately, which makes it harder to identify the exact issue. We need to use separate exception types to catch specific errors. Handling zero division error. This exception is triggered when dividing by 0. If the user inputs 0, we'll display a clear message that division by 0 isn't allowed. Handling value error. This exception occurs when the user enters something other than a number, such as a string. We'll catch this and show an appropriate message indicating the invalid input. By using specific exception types, we can better guide the user and make the program more robust. Let's run the program and first enter two valid integers. It's showing the correct answer, which indicates that there are no exceptions in the input. Now, let's run the program again and enter 0 as one of the values. You can see that it returns the custom error message we provided under the zero division error exception. Now, let's run the program again and enter a string value as input. You can see a custom value error is raised, indicating that the value you entered is invalid. We can also use the else block in a try-except structure. The else block is executed only if no exceptions occur in the try block. If an exception is raised, the else block is skipped, and the except block handles the error. This helps separate error handling logic from the normal execution flow, making the code cleaner and more readable. Let's run the code and enter valid values to check if the else block executes correctly. If there are no errors in our input, the program should run smoothly and display the result from the else block. Now, let's run the program again and enter 0 as one of the input values. You can see that a zero division error occurs, causing the except block to handle the error, while the else block is skipped. We can also store all of Python's built-in exceptions in a variable. The except block catches all exceptions that inherit from Python's built-in exception class and stores the error message in a variable. We can then print this variable to display the specific error message. In this example, we have stored the error message in a variable named e, and then used the print statement to display the error message. And if there is no error in our code, the else block will execute and display the results. Now, let's run the code and enter different values to see how the except block catches exceptions. You can see that when we enter a string as one of the input values, it returns a type error. This helps in debugging by displaying the exact error message, and is also useful for logging errors instead of directly showing them to the user. We can also use the finally block at the end of a try except block. The finally block in Python is used to define code that always executes, regardless of whether an exception occurs or not. It is typically used for cleanup operations such as closing files, releasing resources, or disconnecting from databases. Key points. The code inside the finally block always runs after the try and except blocks, even if an exception occurs. It ensures proper resource cleanup and maintains a consistent execution flow. The finally block executes even if a return or break statement is present in the try block. Now, let's take a look at some basic exception types that help catch the most commonly occurring errors in Python. 1. Value error. A value error in Python occurs when a function receives an argument of the correct data type, but an inappropriate value that it cannot process. 2. Zero division error. A zero division error occurs in Python when a number is divided by 0, which is mathematically undefined. 3. Type error. Type error occurs when an operation or function is applied to an object of inappropriate type. Just like we are trying to add the two values, but one of the value is string, so it will return the error message that you can't add a string with an integer. 4. Index error. Index error raised when trying to access an index that is out of range in a list or sequence. In this example, we are trying to access an index which is out of range in the MyList, so we can handle this error by raising the index error exception. 5. Key error. The key error exception raised when we are trying to access a key in a dictionary, which is not exists in the dictionary. So we can handle this with key error exception. 6. File not found error. A file not found error will be raised when we try to attempt to open a file which is not exists. 7. Attribute error. An attribute error occurs when we try to access or use an attribute that does not exist for a particular object. For example, in the following code, we attempt to use the append method on an integer. Since integers do not have an append method, which is only available for lists, Python raises an attribute error. 8. Import error. An import error occurs when Python fails to find or import a module. This can happen for several reasons, such as the module does not exist, the module name is misspelled, the module is not installed, trying to import from an incorrect location,